In this problem, we're asked to find the trigonometric Fourier series for the voltage waveform shown below. And if we look at that waveform and look at its symmetry, this function has half-wave symmetry, and that's characterized by f of t is equal minus f of t minus t0 over 2. And it turns out for this waveform t0 is equal to 4. So half-wave symmetry means, for instance, that a0 is equal to 0, a sub n equals b sub n equals 0 for n even. Okay, so we're only going to do calculations for n odd. And now omega naught is 2 pi over t naught, which is 2 pi over 4, which is pi over 2 radians per second. So now, taking advantage of the symmetry, then a sub n is 4 over t0 integral from 0 to t0 over 2 of v of t cosine n omega naught t dt. So here we have 4 over 4, and then we have the integral from 0 to 1 of 2 cosine n pi over 2t dt, and then the integral from 1 to 2 of cosine n pi over 2t dt. Okay, that has a value of 1. So now let's go through and perform the integration. Okay, so then a sub n is 2 divided by n pi over 2 sine n pi over 2t, evaluate from 0 to 1, plus 1 over n pi over 2 sine n pi over 2t, evaluate from 1 to 2. Okay, so we get 4 over n pi. We have sine n pi over 2 minus the sine of 0 plus 2 over n pi times the sine of n pi minus the sine of n pi over 2. Now, sine of 0 is 0. Sine of n pi, sine of any integer multiple of pi is 0. Okay, so what we're left with is 4 over n pi sine n pi over 2 minus 2 over n pi sine n pi over 2, which gives us 2 over n pi sine n pi over 2. Okay, so there are the a sub n's for n odd. Now, if we calculate the b sub n's, again taking advantage of the symmetry, we can do 4 over t0 integral from 0 to t0 over 2 v of t sine n omega naught t dt. So again we got 4 over 4, and again this is just 1, and we have the integral from 0 to 1 of 2 sine n pi over 2t dt plus the integral from 1 to 2 of sine n pi over 2t dt. So now, performing the integration, we get minus 2 over n pi over 2 cosine n pi over 2t, evaluating 0 to 1, minus 1 over n pi over 2 cosine n pi over 2t, evaluated from 1 to 2. And as we continue to work on the math here, we have minus 4 over n pi cosine n pi over 2 minus the cosine of 0. Okay, so that's plugging in the limits of that term. For the second term, we have minus 2 over n pi cosine n pi minus the cosine of n pi over 2. So now, let's see. We have minus 4 over n pi cosine n pi over 2 minus 1 minus 2 over n pi cosine n pi minus the cosine of n pi over 2. And continuing on, we have minus 4 over n pi cosine n pi over 2 plus 4 over n pi minus 2 over n pi cosine n pi plus 2 over n pi cosine n pi over 2. And let's see, if we combine this term and this term, we wind up with minus 2 over n pi cosine n pi over 2 plus 4 over n pi minus 2 over n pi cosine n pi. Now, this term is always 0. Okay, so what we're left with is 4 over n pi minus 2 over n pi cosine n pi. And again, remember, this is only valid for n odd. Okay, so then the Fourier series, trigonometric Fourier series for this function then is v of t is the sum from n is equal 1 to infinity for n odd. So now we have 2 over n pi sine n pi over 2 cosine n pi over 2t plus we have 2 over n pi times 2 minus the cosine of n pi sine n pi over 2t and that's our Fourier series.